cool, so we don't. All right, folks, this is TLS. Hopefully you're in the right place. Presumably all of you seen the note well, kind of the guiding principles of the IETF. So if you're not familiar with it, you probably want to look it up, but I'm sure by this time in the week, you probably are. And as a reminder, we all want to be on our best behavior during these meetings and treat everyone with respect. Keep the conversations civil. Thank you. The other thing we want to make sure is that for people in the room, that you do log in using the online meeting tool or the on-site tool. There is a blue sheet that has the QR code if you don't have it. Does anybody need the blue sheet, or can we all, I can arrange for it to go back to you if you need it. It's the blue.
I'll pass it around.
Okay, thanks. I think, yeah, and in particular, use that, we want you to join using the on-site tool so that we get an accurate room count as well, so that we don't end up with a really small room next time. And in addition, use that to join the queue, please. I think you probably have that. So we have a reasonably short agenda today, but basically, is there anybody who has any additions to the agenda? Any bashing of the agenda? No. Okay, great. So then we can jump in. Is Stephen here? All right. You are first.
Hey. Okay, thanks. So this is a draft we presented before. So it's Rich Saltz and Ben Schwartz are working on this with me. Next slide. There's the summary. I guess we saw that before. So next slide. There's a picture. Next slide. There's a couple of issues I just want to talk about. That's good. There's an example. And oh, I didn't give you the right slide, but never mind. So this is an example. You get a JSON response which has the ECH config or an alias one. There's an error in that slide and in the draft in that in the alias mode there should be no port number there, which we figured out. So we'll fix that. Next slide. The changes, we just added one thing to the JSON for version 3. I've started working on an implementation of it, which is incomplete still. And we've started kind of seeing issues as we try to write the code. So next slide. So there's a couple of issues to talk about. I think it was mentioned before on the list that if that SVCB the definition of ECH equals in SVCB, if that comes back to this working group, which I guess is the plan, or do we know that's the plan yet? Yes. Probably is the plan, right? So I think somebody mentioned that this could be merged with that. I think it's probably better to keep this separate for now, but just wanted to raise that in case somebody wants to argue opposite. Nope, there's GitHub issues. So there's a couple of those I wanted to chat about quickly, and then I'll be done. Next slide. There you go. I think we probably want to add support for specifying the inner ALPN when using ECH in this. So we'll probably add that. So this is a way for the origin to tell its DNS infrastructure, please include this ALPN in the HTTPS resource record.
Ben Schwartz. I think we should close this as fixed.
Yeah, well, we have to do it, of course. Yeah.
I mean, I think it is fixed in the current specification. I think this is this issue was open in a prior revision, and it has now been closed because
two of the three authors disagree about whether this is in the current draft. Rich, we'll fix it. Right? Okay. Next slide. So we'll include that. So there's, as part of this, basically the DNS infrastructure is provided with ACH config list values to put into HTTPS RRs. And I guess we can't have a must verify, but it seems sensible that you would check that those ECH config values work before you publish the DNS resource record. So we say kind of a way of doing that. I think it seems sensible to have that as a should. So that's what we do, unless people think otherwise. And then there's only kind of one issue. Well, sorry, there's a couple of things about that. One is that you get an ECH config list, so you might have to explode that into individual public values to check each one. So the draft mentions that. And then if you get an alias, again, you just check, does ECH work? You don't have a particular value to check. And that kind of, the first case basically needs kind of a special client, so we just note that. And then there's what URL to check, and I guess we'll just use the .well-known itself as the thing you use when checking, does ECH work? So I think we've kind of sorted that out, and we'll do that in the next version, unless somebody wants to say something else or say it should be a must, which I think would be a bit hard. Nope. Okay, next. Yeah, there's the actual URL itself, which is, if you see the second bullet there, it shows you the URL we have now. I have a test setup that uses different ECH configs in the same doc root. So in the previous version, there was a file name .json there as well. And I just wanted to check. That's probably, everybody else seems to think that's a weird setup, which I guess I probably agree with. So we don't typically have web servers that would have different ECH configs but share a doc root on a file system, I think. Nobody's contradicting? Great, okay. We leave it as is. I close that one. I think maybe one more, is there? Yes. Oh, do you remember this one, Ben? I mean, I always get confused about this. When you're not on port 443, things get a bit more complicated in my head, at least.
Ben Schwartz, Meta. I think we can take this one offline. I don't think that the working group needs to spend time figuring out this. I think it's just a spelling question.
Okay. But I mean, I guess the thing is, I mean, just, you know, I think it is the case that the working group want this protocol to work on ports other than the 443. So we need to make sure that works, right? And I think that was it. Maybe there's one more slide. No. Okay. So that's basically it. There's a few other issues that are in the slide deck. If somebody's looking ahead and wants to talk to any of them, I guess I'm here for another 10 seconds at least. The next step then is to get that bash implementation working, and then probably pop out a 0.4. And I think it'll be kind of nearly ready at that point, and it can just sit waiting until the rest of the world, the more interesting bit, like the ECH thing itself, is done. That's all I had. Nobody has other things to raise? I escape. Thank you.
Unscathed. All right, Dennis.
Okay, so I'm Dennis Jackson from Mozilla. I'm going to give a quick update on where we are with ECH experimentation. So we've been running this in Firefox nightly since 1.04. The Chrome folks have been running it in Canary since 1.05, and Cloudflare have been running it on a fraction of their domains since 21. The telemetry that I'm going to talk about in this presentation, it's all public. You can get it all at telemetry.mozilla.org. It's all drawn from our nightly and beta users. The first thing we're going to look at is how our connection success rate has changed with the use of ECH. So in yellow, we've got a baseline taken from release where we're not using ECH. And then we have in orange ECH Greece. So this is like the testing mode where ECH is advertised in the client hello, but it's not used by the client and it's ignored by the server. And then we have ECH when it's actually being used in nightly in blue. And basically all of this is within epsilon of normal, given that we're comparing a release population against a nightly population, and users of those two distributions look quite different. And just to highlight that the y-axis here starts at 90% to zoom this in. So this is in general pretty healthy. Latency gets a little bit more interesting. We've got the baseline again in yellow, and we see that Greece kind of coincides with baseline as we'd kind of expect. But as we kind of look at the actual usage of ECH, we see it's slightly slower for the fastest 25th percentile, and then it's slightly faster for the slowest 25th percentile. And that's a little weird because when we do ECH, we know we're doing it with Cloudflare, and Cloudflare have pretty great connections. So in general, we'd expect this to just be faster, full stop, everywhere. And when we kind of dug down to look at this a little closer, we can look at our retry rate in ECH. So in ECH, when we make a connection intending to use ECH, there are 3 outcomes. In blue, the connection succeeds. In red, we make the connection, it authenticates correctly, but the server advertises that ECH has been disabled. And we see that's fairly constant throughout this timeline. And then in teal, we have connections to the server where the server's providing us with a fresher ECH config. And this incurs an additional round trip because we have to restart the connection with this new, fresher config. And since about Firefox 1.1.12, this rate has gone way, way up, as you can see. It's not causing breakage for users, but it's not great. And we need to figure out what the root cause is. It could be that it's an issue in Firefox. Maybe we're incorrectly caching some of these ECH configs. It could be an issue on the Cloudflare side, where whatever they're advertising in DNS is not being correctly provisioned. But it's something we're looking at the moment. Since April, we've switched Firefox nightly into a hard fail mode. So here, Firefox doesn't really try to reconnect if ECH doesn't work. And the user is going to get a very ugly TLS error page. From that, we get user reports saying this site is broken in nightly, but it works fine in Firefox. What gives? And we can go and investigate and see what the situation is. So from that, we found 2 sites operated by the same organization, reasonably popular, and they just barf whenever they see an ECH Greece extension. This was pretty concerning, but actually just testing it, they barf whenever they see any TLS extension they don't recognize. So there's nothing ECH specific here. It turns out it's just quite a faulty, quite an old TLS-1.2 implementation. We reached out to the organization, and they've actually committed to fixing it and rolling out TLS-1.3. So happy news. In terms of next steps, yeah, we've got to dig down and find out what's going on with this retry issue. And we're starting some small scale release experiments. So Chrome have announced they'll be doing a 1% trial with release users between now and December. And we'll be starting our own Firefox trial next week. I'm happy to take questions if there are any. Otherwise, I think it's back to issue bashing.
Questions for Dennis?
Alessandro Ghedini, Cloudflare. Just a quick question about your trial. How long is it going to run for?
That's kind of indeterminate. I'm renewing it at 1-month intervals.
Okay.
So we'll see how the data looks like after the first month.
Sounds good.
Any other questions? Super quick. All right, yeah, Stephen, go ahead.
Stephen Pearl. Yeah, so my question's more to the chairs, I guess. How do we interpret this in terms of moving the draft forward? Maybe you were just going to say that anyway, I don't know.
I was going to say, speaking with an editor hat on, I think now we're going to transition into issue closing mode for the draft, ideally trying to close up things or a working group last call before or around 118. And unless like the experimental data that we see emerging from these trials like goes incredibly south, but that is I think the plan at this point.
Okay, so so working group last call before Prague, basically.
I mean, we need to do the work to close open issues
yeah.
that are open and decide which of those are worth including in the draft or which of those are worth punting. So there's some things that we've been talking about for a while in the past. So one example is like, how do you deal with padding on the server side?
Yeah.
And we kind of went back and forth on various designs. Maybe the option there is, or the best outcome there is to just punt and deal with that separately. But I think the intent is for those bigger issues, bring them to the list, see if we can get consensus to either address them or close them. And deal with all the editorial issues as the editors do sometime between now and 118. So
Great.
that is kind of our plan.
It's a plan, so all plans are
Yeah.
But we're not planning another hold after that. We're planning to just move ahead now and get it all done, right?
I'll turn that over to the.
We're not. I mean, unless your experimental results show that we're cratering something, then yeah. So. Yeah, I mean, I'm thinking the plan is that like beginning of the new year, it's with the ISG, and we're
excellent. Thank you.
Right, and so just to follow up on that, on the issues, we'll send a list or a couple messages to the list. Ideally, one per like major top-level issue. Padding, for example, is one, and we'll see if we can drive to either resolution or being like actual PRs against the text or closing them out over the next couple of weeks and months before the Prague meeting coming up. So if anyone has thoughts, I encourage you to take a look at the open issues, weigh in there, or just wait for the emails to come and we can bash it out on the list. Kyle?
Kyle Neckwitz, Meta. Just wanted to add, we don't have any real things we can share yet, but I'm hoping to have something in the next like couple months. It's not going to use DNS, at least initially, to distribute keys, but I hope in the next couple months we'll have something as well.
Just by next couple months, you mean sometime before Prague or like around that time frame? You don't have to be too specific. I'm sorry.
I don't know,
Okay.
And I wouldn't wait on it.
Understood. Thank you. David.
David Benjamin. Well, small clarification on the slides. Chrome is already at 1% of stable, so hopefully we will have numbers by next IETF or something to share.
Lovely. Thank you, David. All right. Super quick ECH update. Thanks all. Dennis, you're back.
Okay, hello again. So this draft is a new compression scheme intended for use on the web PKI. And the main selling point is that we want to enable a migration to post-quantum CA certificates without inflating the size on the wire. It's a fairly simple and self-contained draft, but there's still a lot of details and optimizations that need to be worked out. So as many people probably know, there's an existing certificate compression RFC from 2020. It's reasonably widely deployed across servers and across a number of clients. And it specifies how you do client and server negotiation of the compression scheme in use, and then goes on to standardize zlib, brotli, and zstandard. This draft is just a compression scheme. So for the rest of this talk, I'm not going to be talking about negotiation because it's already handled as part of RFC 8879, and there's no changes there. So we're just talking about how to compress these certificate chains. The scheme is fairly simple. It has two passes. In the first pass, we compress the known intermediate and root certificates. And in the second pass, we compress the resulting chain with a shared dictionary specific to the web PKI. As we all know, typical chain, 3 certs, root, intermediate, and end entity. You might see more, you might see less in practice. But the interesting observation is that all the roots are already pre-distributed to all of the clients. And increasingly, we're seeing clients already distribute the intermediates as well. So for example, in Firefox, we ship a full list of all intermediates with our clients. And we do that both for performance reasons, but also compatibility reasons to fix broken TLS servers that don't have the right chain configured. And so the idea is simple. Why do we need to send these intermediates and roots if we have them on both sides? So we can compress them, and we can compress them just to individual 3-byte identifiers. The first byte is just a separator, and the second 2 bytes are just an integer, referencing the specific certificate. The hard problem is, of course, how do you arrive at what those identifiers are going to be? And to that, we have the common CA database, the CCADB. So this is a database operated by Mozilla. Apple, Google, Microsoft, Cisco, and others are already members, and it's widely used to manage root store changes. So the current CA application process involves registering with the CCADB, submitting your various root and intermediate certificates, and then getting approval from the various root store members. So in the draft, we define how to extract the relevant CCADB certificates, the intermediates and the roots. And this comes to about 2,000 certificates, which we can then give an identifier to, with 3 meg of space. But the nice trick is that because browsers are already shipping all of these intermediates, we don't have to store really anything extra on the client. And on the server side, they only need to offer compression, not decompression. And to do that, they just need a hash to recognize the certificate, and then a map into what the identifier is. So the actual space taken on the server is about 0.06 meg, so pretty small. This leaves us with a chain that's had the intermediates and roots taken out. They effectively don't contribute to the size anymore. But we still have this end entity certificate, and we can split that end entity certificate into stuff that's specific to the certificate. So the public key, the signature, the various SCTs. This comes to about 400, 750 bytes. And then we have a further ½ kilobyte of strings which are actually shared between every certificate that chains back to that intermediate. So these are things like an OCSP URL, the different policy statements, the CT log IDs, key identifiers, and so on. And we can compress out all of these using the right shared dictionary. And we take that kilobyte, ½ kilobyte, and we compress it down to 100, 150 bytes. And now our resulting certificate chain is much, much smaller. For the PASS2 dictionary, at the moment in the draft, we're scavenging the common extensions from CT logs in a vaguely principled way, and it comes to about 100 kilobytes in total. In the longer term, the CCADB would like to host a form where CAs can just provide binary data to use with compressing their certs. And the important thing here is that we need this draft to be equitable for the various CAs. It's obviously no good if we define a draft which privileges the largest CAs at the cost of the newest members or the smallest members. So we'd want everybody to be able to contribute to this dictionary equally. And as a result, everybody stands to benefit. You can, of course, violate this principle and make things much, much smaller. You can get all the way down to about 3 kilobytes without changing the performance impact. But then you really are just favoring, the 5 largest CAs, and we don't want to do that. In terms of versioning, you've probably realized how we're going to keep this up to date, because we're going to have new CAs need to be added to these lists all the time. From looking at the churn in the CCADB, periodically, like annually, is a reasonable time frame for how long we'd like to update this, and potentially less. And the reason is just that adding new certificates to root stores, it's a long process. It typically takes around a year at the best of times. Like Mozilla is quite proud that it takes us a year. In general, to get into every root store right now, you're looking at around a 3-year timeline. And while we'd like to get that down to 1 year for everybody, it's hard to envisage it being less than a year. The other trick we have is that because this draft isn't doing any kind of trust negotiation, we don't have to wait for a CA to be approved into a root store to add it to the dictionary. So when the CA applies, we can add them at that point to the dictionary. And if they're later approved, they'll benefit from compression from the very first day. And the idea then is that we version these dictionaries by assigning a TLS certificate compression code point to each annual version. And then dictionaries are shipped as part of the TLS library. And just to be clear, there's no kind of OCSP stapling here. There's no kind of server-side network fetching. This is all versioned as part of the TLS library and deployed with, say, a yearly software update.
Real quick, Dennis,
Yeah.
there's a couple people in the queue. Tim, did you want to ask a question on one of the current slides, or?
Yeah, it was kind of relevant to the current slide. So do you want questions right now? Or?
Yeah, we can do questions right now.
Okay. No, actually, this is really interesting work. Thank you. One of the things that I wanted to ask you about is obviously with the changes coming in a month or so, certificates are about to get even more regular and a little bit less Wild West than they have been. So I was wondering, to what extent are you noticing that the various very unique features of CAs are things that perhaps are going to be going away in the future, or could go in the way in the future? Does it make life more equitable, since it appears that there is quite an impact, the behavior of the top CAs versus the lower ones? Are the more regular certificate profiles going to make that problem better, or is there anything we can do on the CA browser forum side to help you out with this?
That's a really interesting question. I haven't looked at it in detail. I've been kind of assuming that things wouldn't improve and kind of go from that baseline. But yeah, maybe it's worth talking about that a bit more. And
Yeah,
figuring
no,
out
I'd
how
love
we
to
can
talk to you
improve
about it.
Yeah, that'd be really interesting.
Watson Lad, Akamai, do we need all these CAs? I mean, it seems like we have now a performance reason to really chop down on some of the small CAs where the issuance isn't worth the security risk of the whole ecosystem. Obviously, it's a can of worms, but figure it's all bad.
Yeah, Watson, I think it's a great question, but I don't want to litigate how we run root stores as part of this draft.
It can wait until after.
Thanks. So I have just a couple more just to finish up the presentation. So in terms of evaluation, I did a benchmark from the Tranco top 100K. Looking at the median, you see about 4 kilobyte cert chains. With existing certificate compression, you get that down to about 3.2. With the abridged certs, we get that down to just a kilobyte for the entire chain. And that's actually pretty close to optimal. If you look at the incompressible public key signature data, we're now within about 250 bytes of what we could hope to achieve. On the 95th percentile, things look even better, 5.6 kilobytes down to about 1.5 for the entire chain. So we're shipping an entire cert chain in a packet, which I think is kind of neat. In terms of deployability, the other nice thing about doing it is a compression scheme. We don't introduce any sources of error. So if you're not using a web PKI route and you deploy this scheme, nothing breaks. You might not get as much benefit as you might hope, but it's not going to make any connections fail. It's not going to require any operator oversight. So as a TLS library author, you can enable this by default and know that you're helping people. You're not going to cause them any problems, any grief. In a yearly kind of versioning, we would only be changing binary data. So backporting here is fine. There's no code changes that are coming every year. And yeah, to stress again, it's equitable for both the CAs and the websites. In terms of next steps, there's been a lot of great feedback from the mailing list already, so thank you. I'd like to go back and benchmark how different dictionaries work. So like we can build the dictionary for 21, for 2020, and see how it would work with the CT log chains from that year. And it'd be nice to get some numbers for what this latency improvement is going to look like with classical chains. There are some great discussions on the mailing list, and 3 to call out was basically people looking at improving how these dictionary formats could work, whether pass-2 is actually in itself worthwhile, particularly if we move to PQ certs. Is that saving of 1 kilobyte meaningful if we still have an overall 6 kilobyte chain? And whether there's like a different versioning strategy that might make more sense. So for example, like, we could ask INA to allocate 6 code points up front, so we're good for the next 6 years, or, do it in a more ad hoc process. A particular thank you to some of the people that gave some really detailed feedback. So Panos, Baz, Kathleen, Martin, and Eka, thank you for your detailed thoughts on this. And with that, I'd like to turn it over for questions, comments, and see if there's interest in adopting this.
Alessandro Ghedini, Cloudflare. So there's obviously like a few issues that need to be ironed out, but it's a really interesting solution that to a problem that we already have, for example, with Quick. So it's not just post-quantum. It would provide value like fairly, immediately with our existing Quick deployment. About the dictionary, we sort of got into that discussion originally when we did the certificate compression work. And then we decided, it's not really worth it with all the, discussion that was going on at the time. It might be interesting to revisit that, but at the same time, I guess it's not necessarily like fundamental to the scheme of the compression. So,
Okay, thank you.
Hi, Eric Risquilla. So I think thank you for this. It's interesting and I think counterintuitive work. When you showed it to me, I was like, I'm surprised it works this well. So fantastic. I do think we should adopt this draft. I think there's definitely, I've heard a bunch of comments about how things can be improved and we can iron those out with the working group process. That's what the working group process is for. People famously say that, the IETF takes it from 70% to 100%. I think this seems like it's at least 65. So we should do that. I do have a question, however, for the area directors, which is, the way this draft specifies things is there is a procedure which one follows as a server or a client in order to construct this database. And I am unfamiliar with any situation in which the IETF has ever specified a standard which had such a complicated procedure for assembling a piece of information which actually had to be agreed on by every side. And so maybe this is cool. And maybe it is not, and I'm not saying this, it's not a deal breaker, but if the consequence is that the IETF has to run this procedure and embed this database in the RFC, then that would be useful to know because that will actually change a number of the questions which you raised above, right? So in particular, there's no need to pre-allocate the code points because we'll allocate them later or whatever. So my question for the area directors is it, and maybe if they hit this back to the ISG, is could we publish an RFC which says the way this works is you read the following things out of the CCADB on the following time at the following time of day and the following phase of the moon, and that's what goes in here, or can we not?
Do the ADs want to field that now?
Paul and Roman.
Or have some time to think about it?
Paul Wouters, AD. Yeah, that's a very good question. I will love to talk with more than just Roman on this.
Yeah, just as a escape hatch. So like right now, the dictionary is intended to be part of the IFC to make it easier for people to deploy. We can always move to like dynamic dictionary negotiation, but then you're punting it to applications to go and find their own dictionary, which isn't like super satisfying.
Yeah, I mean, so there's a room. I don't think we should decide on the design or even kind of talk about the constraints. I think we should go to the ISG, kind of talk through what the space is of kind of options, and maybe they'll inform the kind of the way to go. So let's not preclude anything here. So we'll take an action.
Great, thank you.
So, are you done? So my name is Deb Cooley. I work for NSA. My question is, you're only planning to do this for the, I feel really loud. Usually I have to stand on my tiptoes. Publicly trusted CAs, what? Pardon? Oh, no, stop. So you're talking publicly trusted CAs, which is fine. I mean, that's a huge part of the ecosystem, right? But there are a lot of enterprise CAs that are also used that could probably also stand to use this sort of compression idea. Have you thought about that? Probably not, huh?
Yeah, I mean, it's tricky because, we observe in the enterprise space, there's really varying levels of competence at which people run these internal PKIs.
Thank you.
I know some people do a very, very good job, but there's a very long tail of people that struggle.
Yeah.
And that does make it difficult. It's because you have to, produce this list up front and make sure that you keep it up to date. And, we see in practice that people struggle to distribute those intermediates themselves. Whereas in this draft, we're relying on the fact that clients are going to, version this for them. I think it's interesting. We could easily define this for different root stores and make it very generic, and they could then make use of it, but they would still need their own code points, which are available to just be grabbed, as far as I know.
So I will say, so I don't run. I'm a security evaluator, right? So I watch it and tell them what they're doing wrong. But as that person, so we do have to deploy our own roots and our own intermediates and our own subordinates. So generally, our chains are one longer than what you're talking about. But we do have to deploy those and put them into the stores because they're not there already. We don't get them for free like everybody else does.
So yeah, I think you could certainly benefit, especially if you've got longer chains, and you could use the same process that's described in the draft.
Right.
Really just changing, where you pull that initial listing of certs for.
So I think that's a vote for having the draft be a procedure, a protocol, as it were.
We can wordsmith
Yeah.
that a little bit, but at
Maybe.
the moment it already tries to parameterize it a bit on
Both.
which root
Yeah.
CAs are involved. So we can talk about how to make that work.
So my other wonder is whether you could put these compressed objects into the CCADB itself.
Yeah, I think that's reasonable. But again, it kind of comes back to the IETF question of how to
Like, what are you
standardize
doing with
this
this?
and how
Yeah.
to ship it around.
I do think it's an interesting idea. I wonder. I also wonder whether it will help us in the PQ timeframe when things get bigger and bigger. Can we actually put things other places so that we don't have to pass them across the wire quite so often?
Yeah, absolutely.
Awesome. Thank you.
Thank you.
Kyle Neckritz. I'm very interested in work. I think this is a great idea. I'm very glad we went with a 2-byte code point for the compression type. One other use case that I see as potential here, I haven't completely thought this through, but with multiple root programs recently having varying degrees of announcements on trying to rotate roots themselves more quickly, I think there is at some point going to be an issue of trying to maintain compatibility with clients that are not updating as quickly. And if we now have a code point that's potentially in clients saying how updated they are, I think we should be sort of think through like what possibilities that adds, and if that helps us potentially in a server serve different routes or decide which cross signs that we might need to include as intermediates as well. I think that's a potentially very valuable use case of this.
Thanks, Kyle. Yeah, I think that's a really interesting question on the trust negotiation. It's something like David Ben and I were talking a bit about recently as well. In this draft, I'm trying to steer a little clear of that insofar as like this is trying to be quite slow moving so that everybody can really benefit from it. I think in terms of like the rotating of routes themselves, there's still some stuff we need to work out there around the threat model and how that helps. But yeah, it's really interesting. Thank you.
Jonathan Hoyland, Cloudflare. This has sort of been addressed in the Zulip, but I just wanted to bring it to the mic anyway. This sounds like you might be opening up another venue for the TLS crime attacks. If you look in the Zulip, it's been explained that they don't apply, but like put it in the security thing so that people like me don't go, does this? Like,
yeah. Okay. Good to know. Thanks, Jonathan.
Rich Sauls Akamai. Yeah, I think this is really cool stuff. There's obviously some things around the edge that we'd want to address. I would say fix, but address. Just make sure there's a toolkit so that all the other server operators can easily generate the database. Right? Obviously, you will, and Chrome is open source too. But if my developers don't have to write one, that'll be easier for us to adopt as in CDNs.
Great. Thanks, Rich.
Yeah, Martin Thompson. I'm in favor of adoption. To answer some of the questions before, I don't want to rely on the ISG going off to their ivory tower to make some decisions about this, and I think the community can probably make a decision about the question of procedural versus whatever, though I think it does need to be a broader discussion than just this working group. So there is that, but my preference would be that we focus on just doing the one for now, and then talking about codifying practices if it turns out that we need to be able to update more frequently. So the first version of this, I think, would be a fixed thing, and the second one or subsequent ones would at some point do a little bit more. To that point, those folks who want their enterprise certs in here have the option of registering a code point based on the existing procedures that we have. And I think that's a very good strategy for someone looking to get the sort of performance advantages that accrue to something like this in those sorts of settings, particularly for those larger enterprise settings. it's not particularly difficult to go out and write the necessary applications in order to get your code point and have that work.
Yeah, I think it's just specification required, or maybe even experimental basis for.
Yeah, and it's possible that you could put a little bit of guidance in this document. You know, if you want to build your own, here's a sort of template for how to do this. We've done this in other documents as well. You've got your FF0, whatever it is, prefix that you've got there. There's also the potential to use that to expand the effective code point space for diversity there.
Yeah, so if you do it at that point, it's going to break if you've
that's true.
If you misnegotiated.
But if you're talking about a setting where the clients need to have your roots anyway, then you're potentially in a situation where having them know the compression dictionary is not particularly big jump beyond that. So I think we can make that work, but I would sort of caution. Let's keep it to the simple thing for now. Work through the problems there, prove that it works, and then talk about the iterative and programmatic version.
Hi, Ori Steele. So I'm still trying to wrap my head around the idea. It sounds very interesting. Am I right to say that you're sort of exploiting some structure within the transparency logs to build a kind of domain-specific compression? So this is a general sort of thing that can be pulled out and used in other transparency scenarios, such as the supply chain transparency work or key transparency work, where perhaps some part of this compression piece might be generalized, and it seems related to the question on if you're specifying that compression dictionary in the right sort of way, perhaps it can be reused in other contexts.
Yeah, that's really interesting. So at the moment in the draft, the reference to CT is just for scavenging these extensions. So, it's quite ad hoc because I wanted to be able to do some evaluation without having to ask a bunch of CAs to provide me with example profiles. But the original motivation for this work was actually looking at running a CT log more effectively, right? Because you can use this for compressing the individual records. And yeah, I think there's some things probably worth exploring there to see if we can make it work.
I'd love to chat with you after.
Yeah, that'd be great.
Yeah, so partly I have to say what Martin had said, but I think an observation that should be obvious, but just to make sure everyone's on the same page, nothing prevents a client from supporting concurrently multiple compression lists. And so it's perfectly straightforward for a client to support generation 1 on generation 2, but also generation 1 and whatever proprietary stuff that your enterprise is configured. And so it is not necessary for that enterprise, and in particular, it's not necessary for that enterprise to populate their list completely. All they need to do is populate it with their own certificates, which can be a very small dictionary. So they don't have a giant challenge extracting it.
Yeah.
So I think that that's a pretty good answer to the problem of how enterprises deal with this, because it only burns two bytes in the client hello and nothing in the server messages. And if it turns out that we run out of compression code points, well, I'm sure we can invent some more.
Yeah, absolutely.
Ben Schwartz, Meta. So first of all, I want to note that I haven't heard any discussion of the privacy implications here. If there is no explicit versioning, then there's very little leakage here. But the more configurable this client hello option is, the more it reveals about the client in plain text. I think there's some threshold at which I would say this can only be used with encrypted client hello.
So in terms of the privacy leakage here, the intent here is that every single client can deploy the same compression dictionary. So there's not going to be like a Google dictionary and a Firefox dictionary. There's just going to be everybody that's using this draft is using the same code point. So that there's no which is much less than what the current client hello already reveals, because it's specific between different Firefox and Chrome versions already.
So it's incremental leakage, right? It's on top of any existing fingerprint ability. No,
it's not necessarily. It can be completely redundant information, right?
Sure. If there's truly no entropy in it, then it's 0 bits of additional leakage on top of the existing situation. But that's a little hard to believe. You just mentioned that there's multiple versions, so there's going to be rollouts of these versions in periods where clients disagree. We've just heard discussion about potentially inviting enterprises to advertise additional compression algorithms there. So that would be highly identifying.
Yeah, but I think it's worth understanding the wider context there. Like, we already give enterprises switches to do their own TLS config anyway. So for example, if you're a regular enterprise and you're running TLS-11, like that's obviously traceable over the network because everybody else has turned it off.
Yeah, but that's like also obviously a super terrible idea, whereas this is kind of a good idea.
Yeah. Yeah, and I would also, kind of refer to stuff like with TLS-12 that people are, again, widely using, which reveals the server certificate in plain text, for example. Like, that's a lot more information about what a client is up to than what this is revealing, which is just that you had a TLS library update in the last year.
Sure. So I want to remind people to think about that. As a CTLS co-author, this is a lot like one of the components of CTLS, and I'm sure this has gotten more attention and love than the CTLS version of this has. Maybe we can just backport it and rip out a bunch of text from CTLS, or we'll have to think about that. I do think that a 2-byte code point space is not comfortably big enough to invite all of the enterprises in the world to mint their own compression code point. I really think that we need to be a little careful about that, and I think probably the right answer is some version of the pattern we've seen many times, where the short code points have strict requirements and the long code points are easy to get.
Yeah, and I think that is the current format for the current compression points. Worst case, we can always mint certificate compression with a 4-byte identifier if we have to.
Alessandro Ghedini, Cloudflare. There is like the initial range is sort of reserved, and then there's a longer range at the end for experimental use. But anyway, I wanted to reply to the whole crime discussion. As far as I remember, there's actually text in the RFC. So if that's the case, I don't think we need to repeat that in every draft that actually uses certificate compression. And also, like, if it wasn't clear before, I'd be interested in implementing and deploying this.
Oh, great. Thank you.
Real quick, Dennis, may I suggest on Ben's fingerprinting comment, maybe just add a couple text lines in the security considerations, basically saying what you said at the mic. Cool, thank you. Thank you.
Bas Esteban, Cloudflare. This is great. I'm in favor of adopting. Have you got any performance metric on how on CPU cycles required for decompression client side?
Yeah, I don't have anything for you at the moment. The dominating factor is Z standard, and you can run that between minimum and maximum. The server can choose whichever level of compression it wants to use. The difference in actual compression ratio is about 100 bytes. So if you want to use the fastest possible Z standard, you can. You don't lose too much from that.
Thanks.
Thank you.
So unfortunately, the way that so I agree with you, you can mint more a 4-byte compression scheme, but unfortunately, the way that the compression system works in TLS as opposed to say Quick is that the bigger numbers do not take up any less space than the smaller numbers, and so it's not useful to. And so the current design is not helpful to segregate the popular ones and lower. That's just a convenience for allocation. It's not a performance optimization. So I think if we were to do I think we're gonna have one or two attitudes. One could say that since these are first come first served, we'll watch the repository or whatever their spec required. We'll watch the repository, and if it starts getting half full, then we'll make a 4-byte version. We can make a 4-byte version now too, or an infinite or a variable length thing, but now or whatever, right? But I think, but it's certainly true that there's not enough room for everybody to have one. But I think my suspicion is we'll actually see very little use of that by enterprises, because enterprises typically people are on the fast network anyway, and so it's not that big a deal. And so I think it's probably be fine. But if it's not fine, I think we can find it fast enough. But as I say, I really got to say that that right now it doesn't help you to use small code points.
Yeah, absolutely. It's fixed at 2 bytes.
All right, thanks, Dennis. There seemed to be pretty clear interest in this document in the working group, but in the interest of being, I guess, complete, I'm going to do a quick show of hands just to see, if everyone who hasn't yet spoken up could do so in favor of adopting this or not. So, yeah, in me echo, yeah. So I'm going to start that now. Okay, I mean, it seems clearly going in one direction. Only one person did not raise their hand. If they would like to come to the mic and say why, free to do so. Otherwise, we will confirm on the list. And, all right, thank you, Dennis.
Thank you.
Next up, we have Rich for TLS 1.2 is frozen.
Okay, hi, Rich Sauls, talking about a draft. Next page, slide. Okay, so at the last IETF, I committed to, we'd do a, I'd write a draft saying that 1.2 is frozen because the consensus was that we can't deprecate it yet. The industry isn't ready for that. So what the hell? I'm not an OMCOM chair anymore, I got some time. So the intent by saying frozen, common term, many may not know it, there's no new changes, right? We're not going to add new things. We're not going to add new signature algorithms, new certificate types, and so on. But there may be deprecations because attacks will get stronger. And so we'll find the next version, we'll find Beast 2 or Son of Crime or something like that. Thanks to Nimrod Avram for joining as a co-author. He made many improvements, probably wrote about half the draft at this stage. Next. No new algorithms. You can register ALPN and key exporter labels. This is what the draft says. Otherwise, no new registry entries of any kind. That would be in the IANA instructions and the designated expert instructions, of which I'm one. We need an annotation for all of the registries to say something, so you can say something like this is for TLS 1.3 later. Like, for example, when we standardize on quantum safe algorithms, TLS 1.3 or later. In particular, this would imply no post-quantum support in TLS 1.2, which might help be a driver to TLS 1.3 post-quantum. Next. Impact on other protocols. Any new protocol must support TLS 1.3. If there are deployment concerns, such as we're documenting a protocol already in widely use, we've seen that happen with with various crypto algorithms, sometimes get documented. The draft says if deployment considerations were concerned, they may also say TLS 1.2. Next. Requesting adoption. Wait a cycle, and at the next IETF, I think it's going to be ready for last call. So, questions?
Mike, go ahead.
Hi, Councilworth. If somebody discovers some fatal flaw in the logic documented in 1.2 and we need to go back and actually do a security fix to some core logic, I think in practice we would just do it, but the way you've worded this is we wouldn't be allowed.
Well, I'm not sure. I don't think we'd actually changing. Yes, we can always put out, if we have to change, say, you're talking about like the state diagrams or the message flows. If we found a security flaw in TLS 1.2, I don't know. The IETF may say, well, clearly 1.2 is broken, don't do it anymore. And all the vendors would just fix it. And maybe somebody would issue an RFC that says, this one, TLS not quite dead yet.
Jonathan Hoyland, Cloudflare. Just to future-proof this, maybe don't say must include TLS 1.3, because then when we're trying to deprecate it in 30 years' time, we'll be like, oh, we still have to include 1.3.
That's okay. Yeah, the current, yes, the currently specified latest version. Yeah, that's a good editorial comment to make. Thanks. Hope I remember it because I'm the one taking notes. So.
Alex Shanowski, Jonathan just said what I was going to say. I was going to ask why not 1.3 or newer. Is 1.3 enshrined forever intentionally?
No, it was just because, yeah, somebody put in the notes or send an email, it should say whatever the current version is. Thanks. Thank you, Martin.
Kyle Eckritz. I think this is the intent here, but when we say TLS-1.3 as a default and then TLS-1.2 as an option, we really mean a negotiated support. Right?
Yeah. Yes. Yeah. It's what you spec in the the min max versions that you negotiate. Yes.
Even though on the open internet and the user-facing internet, TLS 1.3 is prevalent plus plus. For enterprise deployments, I don't think that's the case today. And if we are to add stuff like workload attestation, I'm a co-author on one of these, but never mind. The notion of attestation for enterprise workloads, enterprise APIs, we're not going to be able to do that for the protocol that people are actually using today.
Okay, so we're not the protocol police. I mean, if they're not going to deploy 1.3, which is the official standard now, I mean, yes, I understand there are deployment issues, and this is just trying to say, shouldn't do below 1.2, which I think the industry's pretty much already moved to. Of course, enterprises aren't moving as fast.
Enterprises are never moving as fast, and I think we're shooting ourselves in the foot, us and the industry, with this blanket decision not to touch 1.2.
I'm curious, what do you think we might need to change in 1.2? Adding new encryption algorithms and stuff?
So that specific draft I have in mind is adding some new code point to the certificate payload, but it doesn't matter. It's something somewhere inside of the TLS handshake.
Okay.
David Skenazy, process enthusiast, apparently. I think your draft attempts to do two things that are somewhat separable. The first one is any new protocol running on top of TLS should be recommending 1.3 and not saying you do 1.2 and then maybe think about this cute new 1.3 thing. So that's kind of a BCP, 100% agree with you. That's like it doesn't even need to be binding. It's like common sense, and that way publishing it as a BCP, so if someone tries to do the wrong thing, someone can go, hey, look at the BCP, you're holding it wrong. So that 100% good. The other part of your document is you must not touch 1.2. And so let's game this. Let's say, this gets published, we move forward 6 months, and the scenario you described, we find a fatal security flaw in 1.2 that can be fixed either with, let's say, something like extended master secret in 1.2, or it can be fixed by just use 1.3. And then we have a choice to make. We can use either of these. And at that point in time, we will make that decision based on that vulnerability with the information we have. The thing that this seems to forget is that any RFC can look at any past RFC and rip it up. All you need to do is the update tag. And so at that point in time, whether this RFC was published and written or not will not come into that decision, because that decision will be informed by deployment experience, security, like importance of the vulnerability and so forth. So I don't see the work of saying don't do 1.2 as particularly useful, because at that point, that will just be a nudge. And personally, I think, implementation aspects, deployment aspects matter much more than an RFC that someone wrote at some point in the past. What I might suggest as a process side to do this nudge could be a change to the charter of this working groups. We all love recharters. They're fun and they give our IDs job security to specifically state things like that. But even then, I'm not convinced there's much of a need there. But again, I don't feel I don't
Yeah.
feel too strongly. I won't like get in the way of this, but I don't think there's a need for that part of the document personally.
I think the intent, or certainly the intent as I was writing down what I thought the working group feeling was the working group didn't want to do anything more on 1.2, and we wanted to signal that to the outside world. The writing may not be good enough or not, and maybe the working group now, because what you've said and Yaron has said, maybe that's not the consensus of the working group right now. Fine, we can have a one paragraph BCP. I'm fine with that too.
If we go into it with that message, then that sounds reasonable. I won't like object to this. Thanks.
Watson Lad Akamai, I really like this draft. I think we've over the years had a number of cases where people have been scared of the word depreciate. There is a word for saying you should start thinking about moving to a new thing, and that word is depreciate. I understand why you can't use it, but I think people need to get over the meaning of this word and realize that we need to do that. We need to have a way to signal you should start moving a new thing. I think this draft does that. Contra David, I think that recording the sense of this working group in a way we can point to and say, here are the reasons why we said that we don't want to work on 1.2 anymore. We want to put our efforts on everything new on TLS 1.3. Your upgrade path is TLS 1.3. I think it's valuable as a way to sort of record and crystallize our reasoning, regardless of whether or not it's actually effective forever in the process. Obviously, we can go back and revise it, but just writing it down and remembering why we didn't do that has an effect.
Actually, I think it's Florence. Are you in the queue?
Ben Schwartz, Meta. I support this. I think it sounds like there's been some concern specifically about how this would interact with a hypothetical catastrophic security issue. Maybe you want to consider a term like feature freeze. I think people talk about freezing in different ways. A feature freeze, I think, conveys your idea that there's not going to be any new functionality added to TLS 1.2, which is a little bit different from saying that we're not going to try to fix serious issues, although you can perhaps say that we'd like to avoid that, and we'll try to avoid that. I do think this is valuable as an IETF consensus informational document to the outside world. Like, don't expect us to do anything interesting with TLS 1.2. It's not going to happen. And as an enterprise, if I imagine myself as an enterprise system administrator, I might actually rejoice to hear that my old systems are not going to have anything interesting happen to them. And they're just going to stay exactly the way they are. And there are going to be very few updates to the libraries I depend on and so on.
Yeah, bug fix releases only.
Hi, Flo Driscoll, UK NCSC. So I don't know how many enterprises there are out there who are still using TLS 1.2 because they're relying on features of TLS 1.2, but I would suggest it's non-zero. And I suppose this concerns me a little bit because it's completely reasonable that those enterprises would want to continue using TLS 1.2 in a securely configured way and would also want future features. And I appreciate that that's not what the working group as it stands wants to work on, and that's fine. But if somebody turned up in a year's time and said, I want to work on this, there is support to work on like a particular feature for TLS 1.2, then it feels like addressing that proposal at that time with the people in the working group then is the right way to go about it, rather than saying, as of today, if you turn up in the future and want a feature, then no, we're not doing anything. So, yeah.
Hannes, I think the document, in the way it's worded, conflates two issues. One is the question of what the group wants to work on, and the other one is how the deployment situation looks like and recommendations regarding its implementation and use. And I'm fine for the group to decide that it wants to spend its energy on extensions for TLS 1.3, but I feel uneasy about conveying the message that it's not a good idea to use TLS 1.2 and implicitly DTLS 1.2, because some of the industries are moving much slower than the web industry, and so they need much longer to transition over to 1.3. And that's my worry. You implicitly, you can read through the document, you're implicitly saying like, well, switch to 1.3, which, because we don't consider it to be good anymore. and the
Okay.
1.2 version, which is
No, that's fine.
Yeah.
So I think that's probably a fault of the writing then, because we did explicitly say, you can configure TLS-1.2 securely. And maybe we need to fix up some of the other wording.
So this is Deb Cooley from NSA again. It pains me to say this, but it is true that enterprises do still need TLS 1.2. There are some things you cannot do with TLS 1.3. When TLS 1.2 does go away, which it will eventually, because it will become vulnerable, those enterprises will have to do things differently. So while we encourage them to work on that now, they're not there yet.
Sure.
I think I am next. Yeah, good. So I guess first, so I think first of all, I'd observed that the charter actually does kind of like make a bunch of hand waving about how we don't want to work on older versions. What it specifically says is changes or additions to older versions of DTLS, whether it be extensions or cipherkeys, are discouraged and require significant justification to be taken on as work items. So I think I can imagine strengthening that text somewhat. I certainly, I certainly agree that like if we ran into a situation where there was like some like massive vulnerability in 1.2 and it could be fixed by like changing one bit in the header, we'd probably just like bite the bullet and do that. So I think I think that would probably like the extent to which what we want to do is say like do not expect like any improvements to 1.2, like any meaningful improvements to 1.2. I think that would be like probably the easiest way to do it, as David suggested, we modify the charter and basically like sharpen those points a little bit. I think we say like, I don't want to worsen it too much, but basically say like, we're not going to do any more of these, and the only thing we do is security fixes. I think the easiest thing to do that probably rather than having RFC. I don't really have a strong opinion about the other pieces, but I think if what we're trying to signal is we're not maintaining this we're not doing anything other than like maintaining for security, I think the charter is supposed to do that. I guess I would say we would have to make the charter change. Even if we publish this document as an RFC, we then have to make the charter change to say the thing this document says. So I would ask whether we could just change it.
So just because I did this talk last time, right? That's where we started, and then everybody said it was better to have an RFC to point at. So I'm fine if we walk back and forth. That's why we wanted to do this discussion. So.
Nalini. Yeah, I mean, yeah, definitely there's a non-zero number of enterprises that use TLS 1.2. I think maybe a little bit is a solution is like, maybe the title is maybe part of the problem too. I mean, because there's two different things. I mean, definitely everybody needs to be encouraged to go to the latest version. No question about that. People are slower than we would like. Of course, no question about that. But I think if the message you're trying to convey is that the group doesn't want to do stuff, it's not quite clear to me that TLS 1.2 is frozen. It's not clear to me that maybe that is maybe a little, what I mean? It's like that's a little different statement than what you're trying to do. I don't know if that makes sense to you.
Okay. No, I think whoever it was that said, oh, no new features in 1.2 is a better expression of the sentiment that the document was trying to get to.
Yeah, Arnaud Tadei, Symantec. So I'm not going to discuss whether we should or should not, but my point is more about, we speak about enterprises, but enterprises are not in this room, right? If I make a poll, none of the people we are talking about, like energy providers, retail, finance sector, they are not in this room. Just to give you a scale on security side, I recently asked a question to a group CISO of a prominent energy company. What is your strategy for the next 5, 6, 7 years? He said, Arno, my strategy for the next 50, 100 years. And I will leave it at that. Thank you.
Hi, Roman Dinelu, No Hat, Carnegie Mellon University. I was quite persuaded by what David said earlier. I know that there would still be 2 short drafts, but I would separate the future design guidance for all the other protocols for what we would say about another existing protocol that we have.
Would that then go to UTA?
Yeah, actually, yeah. Off the top of my head, yeah.
Okay.
David Skenazy, security enthusiast this time. I'm somewhat confused about the comments that have been made at the mic line about enterprises and TLS 1.2. and about talking about features that TLS 1.2 has that TLS 1.3 doesn't have. My read of the situation as an individual contributor is that there is some pretty strong consensus in this working group that those features that TLS 1.2 has that TLS 1.3 has are considered bugs. That's why we remove them in TLS 1.3. And actually, you can bring those back in TLS 1.3 if you want. There are drafts that have been written about bringing back semi-static keys. You can even write a draft that puts the certificate in the clear if that's something that you think is a good idea. And so I'm kind of confused by this idea that, wait a minute, enterprises are doing 1.2 and therefore we should work on these things. I don't think this is what these enterprises want. What these enterprises want is browser vendors or server vendors to be deploying these TLS 1.2 fixes. I hate to be a spoiler, but they won't. Like, I'm not talking on behalf of any browser here, but I think probably suspect that if there is a new feature coming in, and even if the spec says we'll do it in 1.3 and in 1.2, it's very possible that multiple browsers will say we're only implementing this in 1.3. So all of this talk about enterprises in 1.2, that's all nice in theory, but I don't think that should have any impact on the work we do here, because let's talk about the people implementing this. Those are the main constituents of TLS and what happens in this working group.
So I feel I'm not going to. My only response is I kind of feel obligated to channel Peter Gutmann, but I can't do the accent, so I won't.
So when I say that enterprises rely on it, doesn't mean I agree with them, right? They do rely on it. They do feel that they need to have boundaries around their little walled gardens, right? It's their little favorite thing to have. And when your resource is on the inside that needs to communicate with the outside, then you need to be able to make sure your little walled garden is safe. And so the way they do things today, you can only do with one protocol and one algorithm suite. I don't like it either. I don't usually work on these things because I might not be polite. So, so yeah, no, we divide and conquer, and there's another guy that works on those things because honestly cannot do it, right? So there is change afoot within the enterprises that I support to do away with some of those things. Those people are, they're very persistent and very persuasive, and it's difficult to persuade them to do things a different way. And I do agree with you. You could design it another way. The problem is they can't build it. They have to buy it. And so it has to be already in these products ahead of time, right? We talked about this back during the little, the little times when we were talking about RSA and TLS 1.3, right? We talked about the fact that you could use static ECDH, you could use all sorts of stuff, right? But it has to be implemented in a product. And a lot of these product developers won't put it in there unless it's a standard. So I agree. I mean, that's why I don't know that I've ever come to the mic to talk about this before, because generally I don't agree with the whole position. So, and that's me personally, not, exactly. So, and in December, I will be an individual. So you know what I mean, right? So I think it's hard, right? I don't want to see TLS 1.2 deprecated so much that we can't continue. You don't want to cut these people off at the knees, right? You do want them to migrate into something more sensible. It does take time sometimes. I mean, the speed of government, can't tell you, slow, really slow. So, yes, oh my God, even by ISO standards. Or let's not talk about, yeah. So that's why I think you can't, I think we need to be careful. I do agree that you don't want to add new features to it. I do agree that you don't want to spend any time working on it. I do agree that you want to signal to the outside that you're not going to do anything more to this. I'm fine with all of that, right? I just don't think you can't, please don't deprecate it. No, I know well, yeah, but there's a draft that deprecates that algorithm. Not his draft.
Quick response to David. The reason I was talking about 1.2 in the enterprise is not the funny stuff that we all hate that would mean changes to browsers. It's mostly about service to service traffic, so API traffic. And to give one good example is about a year ago, my own team had to add TLS 1.3 support to one of the most important open source service mesh implementations because it wasn't there. And to this day, 1.3 is not configured by default in that particular package. So it's all about inertia.
Watson again, I'll be very brief. If we need to send a signal after 5 years that people need to be moving this way, we need to send that signal, and the word is depreciate. If nothing else is going to get their attention, and they need to hear, deprecate. Sorry for the pronunciation. But if nothing else is going to get their attention, that's what they need to hear. And if the fact that they're complaining about it and they aren't complaining about anything else says that that's the word we need to use.
All right, queue is closed at this point. Thank you, Rich. I think the chairs do agree that there are kind of two fundamental pieces of this draft. The first of which is the recommendation that DAO must use TLS 1.3 going forward and what is generally considered good practice. And the second of which is that TLS 1.2 is, for I guess some definition, frozen, feature frozen, what have you. We would like to see them kind of split up. And based on the discussion that we had last time at the meeting and the comments at the mic here, I'd like to do a quick kind of show of hands to see who is interested, if the working group is interested in adopting that TLS 1.2 as frozen component of this draft as an item for this particular working group. Do an echo or meet echo now. Please let us know your thoughts. The charter question that was raised by Ecker, I think we can address that separately. Shouldn't be too much work to recharter on the basis of this particular document being adopted. Okay, so we have 54, 51 for, 14 against. Does anyone who explicitly did not raise their hand, do they want to come to the mic to say why? Provide new information to the group that has not already been presented at the mic as to why this perhaps should not be adopted by the group. Okay, if not, thank you very much, Rich.
If you're planning, I assume you're planning on confirming to the list.
Absolutely.
Give me a week or two to like split the draft and fix some of the editorial comments.
Sounds good. Yeah, just shoot us a message when you're done, and then we'll take care of it.
Thank you.
All right. I think then last up we have Boss or Tom. Not sure. Do you want to drive or would you like us to drive?
Would whoever took the notes while I was talking put the name in the notepad? Thank you.
So because we're already working on putting post-quantum into TLS with authentication with various drafts, I thought it would be good to give an update on the new post-quantum signature schemes that are on the horizon. As you might already know, NIST picked already 3 signature schemes, Dilithium, Falcon, and Sphinx, which are going to be have final standards probably mid next year. So why more? It's because they are not that great. So So Falcon, I mean, all of them are large. Falcon is the smallest signatures and public keys. But the problem is to create signatures, you need with acceptable performance, you need floating point arithmetic, which is really hard to do in constant time. So that's not great about Falcon. The lithium is easy to implement and is fast, but its signatures are quite big and just like its public key. Then there's the question of security, which is not, well, then there's Sphinx, which definitely is secure, but the signing times are terrible and they're rather big. There are a few ways to cope with this. So by not changing the signature scheme, but changing the protocol. So various variations on suppressing intermediates, such as Dennis presented. We can replace the handshake signature by CAM, off-CAM, or also known as CAM-TLS. And there's bigger redesigns, such as Merkle tree certificates. But the easiest thing, of course, would be to have a better signature scheme, and I guess in this degrees. That's why they launched an on-ramp with a lot of submissions. This will take probably many years, at least 3 years, I suppose, before anything comes out of it. So 2 weeks ago, 1 week ago, they published all the submissions. So it would be nice to have a look at them, how they affect TLS. So these are the 40 submissions, and within the first week, these of them were already broken, or actually, these are not all that are broken. After I prepared the slides, also DME sign, the security of that came into question, although and of Felicia. These are not necessarily completely correct, right? Because someone sends an email, I think this is broken, and that attack might or might not be correct. Not all of them come with scripts to actually break it. A few of them do. Okay, of them, not all are actually practical. So these ones are the ones that have verification times which are more than 5 milliseconds. Then these, which are crossed off, have signatures larger than 3 kilobytes. I really wonder why they bothered submitting. So for TLS, there are 2 use cases where you have a public key, so such as with certificates and the lease certificate, and where there's no public key, such as SCTs and root certificates. So for public keys, so for certificate usage, you want that the public key plus the signature is smaller than 4 kilobytes, because otherwise, why bother? You can go with dilithium. So then we're left with EHT, which I think is broken. Only these few were left. If you look at them, then the best one is DME sign, although that one is there's an attack on it published 2 days ago, which might or might not be fixable. And after that is Mayo, and then we already have Falcon and Hawk. Hawk is quite similar to Falcon, so but it's better. But in the security assumptions, it's quite similar. So the question is whether that will be added as one. Anyway, Mayo looks here very interesting with a public key of 1 kilobyte and signature of 300 bytes. Actually, Mayo has a smooth trade-off between size of the public key and the size of the signature. So you can increase the size of the public key and decrease the size of the signature. And they've chosen 2 trade-offs for the submission. Yeah, for SCTs or for root certificates, we cross off all the ones that have signatures bigger than 666 bytes, which is Falcon, and we're left with these, which again, DME sign is almost too good to be true. I don't think it will survive. You have various variations on unbalanced oil and vinegar. They are quite interesting. They have public keys of 60 kilobytes and signatures of 96 bytes. So UOV, so that's the plain variation, exists for quite a long time and probably is secure, but it's especially the variations on UOV which decrease the size of the public key that are where security is always a bit uncertain. So UOV looks very interesting. And again, Mayo looks quite interesting with the larger variant with 5 kilobytes public key and signature of 180. So concretely, what could we do? If you just use DME sign, then that adds compared to P256 only 3 kilobytes, and that would be complete. Sorry? And that would be completely mitigated by Dennis's abridged compression. But it did survive the weekend. I don't think it will survive the next weekend, maybe. So Mayo, if we use Mayo is nice. So Mayo has two variants: one with a bigger public key and smaller signatures, and one with a smaller public key but slightly bigger signatures. You can use both variants in the two roles. That adds 3.3 kilobytes, which is practically completely mitigated by Dennis's draft again. Only the signing time is a little bit worse, about 8 times worse than P256, but we're still looking at only 300 microseconds. The security is definitely better than DME sign, but although perhaps there's a big attack on Mayo, we just don't know. It needs the few years of analysis. Then we can also use UOV, which will have 60 kilobytes for the public keys, which is fine for roots and certificate logs. And if we would use Hawk instead of Falcon for the handshake signature, it would add 3.2 kilobytes. If we instead would stick with dilithium, we're looking at 7 kilobytes, which is still much better than the 17 kilobytes we're looking at if we're just using dilithium. And as a final one, I wanted to mention SkiSign, as Watson mentioned it on the list. That would add only a few hundred bytes, but we're looking at a signing time of more than a second and a verification time of more than 35 milliseconds. So I don't think that's workable at all. All right. I lost the... So as a wrap-up, still no perfect drop-in, but it's much better if they at least survive. I want to say that this is all very preliminary, not just the security, but also the performance numbers. We can expect them to change quite a bit. All right, thank you.
Becker, go ahead.
Thanks for doing this. It's really good to see like this data here. So I'm going to channel DGB for a moment, and then ask you to wildly speculate. So the channeling DGB is the point that the key sizes won't change, but the performance may change. That is, we're expecting faster versions of these implementations, whereas the key sizes, of my impression, I think are relatively fixed, and the signature sizes are relatively fixed. That suggests that that things that have good have good numbers on size, but not so good performance might be good things for us to be looking at. So now my invitation to wildly speculate is: do you have any intuition for which of these might get dramatically faster due to someone being very smart?
I think the ones that are actually interesting, Mayo and UOV, they are already pretty fast. Well, Mayo can be a bit faster with signing, but it's already. I don't agree that the key sizes are fixed. So for instance, if we look at dilithium, their key sizes changed a bit, not dramatically, but they changed. Also, key sizes will go up if attacks are better, right? Because if we need to increase parameters to mitigate an attack, then probably the key sizes are going up. So the key sizes will change. They might get better, actually. Yeah, they did for not dramatically, but they can get a bit better. Yeah.
Watson Lad, a computational Turing isomorphism enthusiast. With SkiSign, the main computation is something that has gone a lot faster over the years, and there's probably still some room to squeeze it out. particularly in the signing operation. The main question there is the structure you need to sample from to be good enough, and there's ways to improve that potentially. And the verification times is sort of an evaluation that's, you can look at the graph of like how it goes over the years. So there might be more room.
I'd say it has to be at least 10 times as fast, the verification time to be, but again, 35 milliseconds is a lot.
Yeah, Tom, go ahead.
You to comment on Ecker's comment on the performance of these schemes. We picked 5 milliseconds for verification time with a reason, because 5 milliseconds already seems like quite a lot if you need to verify a bunch of signatures. But it also seems like not so tight that performance improvements are ruled out. So I think that anything within that 5 millisecond ballpark might go down to maybe 1 millisecond, maybe a little bit less. But there's a bunch of schemes in there that have, there's one that has a signing time of a minute, which is, 7 minutes, which is pre-on, which is just very dumb. At least its performance is crazy. If pre-on gets 100 times faster, then it's probably still way too slow, of course. The Internet of Zen is also an approach, as Ecker suggests in chat, but 1 second signing times, I'm sometimes a bit impatient.
Okay, thanks. Any other questions for Boss? No, thank you. We did have one additional topic to bring up, Jonathan. I'm going to summon you to the mic because we're now at the end of our session.
Hi, everybody. Jonathan Hoylands, Cloudflare. I don't have slides because we came up with this 2 hours ago. So there was some discussion about using exported authenticators for things in HTTP. And one of the changes we would want would be to make it such that the client can just send a certificate without having it requested by the server. And so I just wanted to bring that up here as a, does anyone have a particular objection to that that's so bad that I shouldn't bother trying to write an RFC? Excellent. So in the moment with exported authenticators, the only way for a client to authenticate themselves is the server says, please authenticate yourself. That seems very unnecessary. And I don't see a reason why the client can't just be like, hi, I'm Bob. Yeah, so I want to propose a change to the RFC or like a new RFC or whatever. And if someone doesn't have a really strong objection to that, I'm going to write it and try and get adoption. But if someone's like, this is a terrible idea, I'd like to know before I do that.
So I don't have a strong objection to it, but though I may have an objection when it comes up in HTTP.
Yeah.
But part of the exported authenticator is the context value from the server. And so I guess my question would be, would you be using a fixed context value? Would you be doing some kind of fiat shamir nonsense? Like, what would you do?
That's a very good question. Not thought it through yet, but there would have to be something.
Okay, so it sounds like that's the point that we have to focus on to make sure that we didn't break whatever properties we thought that thing provided.
Yes, that would need to be worked out and proven, preferably.
Chris Patton.
Chris.
I'm a little confused. I heard 2 suggestions. One about like exporting a key, and then another about here's my certificate without being prompted.
Oh, okay, yes. So at HTTP Biz, we had 2 different things. One was just using the TLS exporter key interface. The exported authenticators is another thing that calls the same interface, but is not actually so those were 2 separate ideas. But yes, one potential way of solving the unprompted auth thing is to use exported authenticators, and I would be very keen if we could do that.
And then the other one was
we are going to re-implement exported authenticators with different context strings and call it something different.
Okay.
Hey, Nick Sullivan,
Hi, Nick.
author of Exported Authenticators. I'm going to have to go back on the list. We did have this mode in there. We had 4 modes, prompted and unprompted both ways, but we removed the unprompted client one. Partially, I have to check exactly why, but it didn't match up with any of the security proofs of TLS because it didn't match any patterns in TLS. So there's this idea of an empty authenticator in exported authenticators. There could be potentially an empty authenticator request that's implied. I'm not sure this is impossible to do, but there's a reason it was taken out.
So if I remember, the reason I remembered it being taken out was if you do this in early data, then you can leak the client cert. And so the updated version would have to see, don't do that. But there might be other reasons as well.
Mike Bishop, from the HTTP session, we're just trying to avoid re-implementing something we already did a couple years ago. The 2 changes that we would need to use exported authenticators are this being able to do it unprompted from client to server, and also currently exported authenticators restricts it to only X509 certificates, not any other credential type supported by the certificate frame. Yeah, it's in there.
I'm going to have to go read it again. I didn't know that was there.
Yeah, it says that there's no technical reason you couldn't, but it hasn't been analyzed, so don't do that unless a subsequent document says you can. And so I think you're helpfully volunteering to do that analysis and then write the document that says you can.
Well, I'm already working on the analysis, so the document writing, yeah. There's still someone in the queue. No.
All right, I think that's it, unless there are more questions for Jonathan. And unless there's anything else, oh, did you have something else?
I guess the only thing I wanted to add is we do, as chairs, we owe you guys to finalize the consensus call on the obsoleted text drafts, and then we're going to do the return routability check, working group last call shortly thereafter. So expect working group last call and some calls on an existing working group last call.
All right, if there's nothing else, we can get some time back. Twice in a row, we finished early. Thanks, folks. And we'll see you in Prague.